Here we go. Exercise 9A-C, but mainly 9C. Power rule. Let's see if you remember power rule. So power rule, just where we left off from last session before the bell went. If you remember, just above the power rule was, if you have a power function, such as a x to the power of n, the derivative, instead of doing the first principles, we know the derivative is equal to n times a x to the power of n minus 1. That is essentially kind of like saying bring the n down, the power down, minus the power by 1. How would you do? Example 3a. Can I please have... Let's go with Noah. What would you do in this case here?
I would expand both brackets.
Beautiful. Thanks, team. Let's not speak while I am going through the notes. You need to expand. Normally you can do product rule because it's one linear equation times another linear equation. You can use product rule, but if you don't know your product rule, then you can expand it. And the reason why you expand it is because you get individual terms. So if you expand them, you'll get negative 6x, you'll get positive 3x squared, plus 10, and a minus 5x there. All right? Now they're in the individual terms, you can use power rule on each of them individually. Let's go. Let's test your memory or understanding of power rule. What's the derivative of negative 6x? Let's go with Joe.
Negative 6.
Negative 6. What's the derivative of 3x squared, Sam?
6x.
Good. 6x. And then what's the derivative of 10? Can I please have Ryan? Nothing. Very good. Derivative of a constant is 0. And then derivative of negative 5x? Alex? Negative 5. Beautiful. Combining any like terms, we then have 6x minus 11. I mean, we could have probably reduced it beforehand and then derived them, but I'm just showing that you can differentiate individually. What about the second one? So B, now B has f of x is equal to x to the power of negative 3/4 minus 2 times x to the power of a quarter. I think that was exercise 9. You're still not part of 9C. You're still part of 9C. So, they're in the individual terms. You have x to the power of negative 3/4 and then minus 2x to the power of a quarter. What's the derivative for x to the power of negative 3/4? Can I please have Tara? Not sure? Not sure. So, anyone else wants to have a go? What's going on there? That's a bit freaky. Still working. Cool. What's the derivative of x to the power of negative 3/4? Ranga, you want to have a go?
We're going to do n minus 1. So
Good. So drop down the power. So it's negative 3/4 times x to the power of negative 3/4 minus 1.
Yep.
Now you just got to do it in your head. What's negative 3/4 minus 1? Negative.
Negative 7.
Beautiful. For those who aren't very quick with their fractions, in other ways, because that's a whole number, you can actually just do 4 times the negative 1 and then negative 3 minus whatever that answer was. So 4 times negative 1 is negative 4. Negative 4 take away 3 is negative 7. So you can say it's negative 7 on 4. Okay? So that's the derivative. Again, still the power rule, just with fractions and with negatives. Same idea. Someone have a go with the next one. Minus, now I've got 2x to the power of a quarter. What would that be, Serena? To the power of? Beautiful. And again, if you're wondering where the half came from, it's a quarter times 2. A quarter times 2 gives you a half. And the minus is still at the front. And then a quarter minus 3/4 gives you, a quarter minus 1 gives you negative 3/4. Technically, this is correct, but if you left this your answer in the exam, they do not accept or they may penalize you. Why? What's the problem? Oh, it's true. I forgot that too. What are we missing? Oh, it's not that what we're missing. It's that what they prefer. What do examiners prefer when it comes to your answers?
No negative powers.
That's one of the things. Make sure don't leave your answers in negative powers. They always have it in positive powers. Just like surds or irrational numbers in the denominators, don't leave them with irrational denominators. And sometimes this might be a bit finicky. They don't prefer two terms. So currently you've got term 1, term 2. They do prefer a combined term, especially with general solutions for chapter 6. But look at the number of marks. Okay, so the number of marks also indicates the number of time or space you should be giving it. But where you can, something like this one, don't leave your answers like that. How do we change it to positive powers though? That's probably why they want to see that you know how to leave your answers in positive powers. What would the answer be with positive powers? It is a reciprocal, and it's the reciprocal of this. A lot of students then do the reciprocal of the fraction itself, and they flip it around. No. The rule for index laws is a to the power of negative m is 1 on a to the power of m. So the negative 3/4 stays as it is, but then this one becomes 1 on x to the power of 7 on 4. So if you put it together, it's negative 3 over 4x to the power of 7 on 4 positive power. Okay? And then minus, same thing again. This is the same thing as saying half times 1 on x to the power of 3/4. And this is a more preferred answer. Although it's possible that the examiners may combine those two terms. But you look at the number of marks, I would say this is likely a 1 marker. Okay, so you probably would have just stopped there. You don't need to go more.
Even if the answer is like in that form, or if the answer is in like a slightly different form to what you've done, you still get marks, right?
Depends. So in the exam, they have like a particular line that they all look at. So if they're marking like 200,000 kids, they're going to try to go through it. It's actually not 200,000. It's about probably 40,000 students, but each person will do about a couple hundred. When they mark through it, they have a certain answer line. And that answer line is what they look for, right? And if they don't see it, they'll look up to see if there's any method or whatever it is. But if it's just an answer mark, so if it's a 1 marker, this is what they give. So they'll either give you a cross or a tick. But in the moderation component, there might be questions of how many people didn't simplify it to this point. If a lot of people did, then they're like, well, that's more the preferred answer. We wanted that, and a lot of people did. So those people who didn't, they take you off mark. Another thing as well is that maybe it was the correct answer, but then now the distribution's not good. They need the top end to, give an extra mark to those separating the top end. They're like, you know what? The top end student, the really, really top end, did you notice that they actually simplified this and made it a positive power? Then what they might do is they might say, all right, I do agree. That means the ones with the negative powers, we take off a mark, whilst the people who did do that, we'll give them that mark for it. And so that separates that, so you get that distribution as well. So that's why it's normally safer for you to do the best and most simplified answer just in case, because you don't know when they're going to moderate it to that way. So that's why I'm saying kind of be smart with depending on the marks, whether it's going to be worthwhile doing, so many lines for just 1 mark, because you don't know how it's going to be changed. So where you can simplify. Don't leave answers with decimals unless they ask, that kind of thing. Those little things matter. Yeah? All right, next one. How do you do it when it's a fraction? If you don't know quotient rule yet, what do you do here? So this is another way of saying the derivative. Find the derivative of the function. So instead of saying the function is the fraction and then derivative, that's another way of saying find the derivative of the function. What do you do here? Yes, Rango.
Well, everything's kind of a term of x, so can't you just sort of make it 9 to the x minus 6? And, well, yeah, and then 3x, just no 3.
Very good.
Y to the x.
Beautiful. So one of the techniques is when you get a fraction, you want to simplify. And simplifying, you can use index laws that both have a denominator of x squared. So you can actually split up the fraction 9x to the power of negative 4 divided by x squared plus 3x squared divided by x squared. That's essentially splitting up the fraction. And then you can use index laws. So it's delta dx of. So I've just changed the function to look a bit different. And like Rango said, we are actually finding the derivative of, now x to the power of negative 4 divided by x squared. Remember, you subtract the powers. So negative 4 subtract 2 gives you now 9x negative 6 plus, and then x squared divided by x squared cancels out to be 1. Well, x to the power 0 is 1. So you get 3, and then you're back to power rule. Okay, so now doing the power rule, you can then say, that's what, negative 6 times 9 is negative 54, x to the power of negative 7, and derivative 3 is 0. Don't leave your answer here. It's got a negative power of 7, so I would leave it as negative 54 over x to the power of 7 as my final answer. Okay, so that's what I mean, that in an exam, that is correct. They may take off a mark. I don't know if they will or not. Okay, so it's just worthwhile changing it to positive power because we know that's what examiners prefer. Okay? So far, so good? All right, flip over to the next page. Next page. So that's just doing exercise 9C power rule in a different variety of ways. Let's have a look at the next one. Ooh, what happened here? That's a bit funky. It's a bit laggy today. All right, gradient of a tangent line, y equals mx plus c. We know that when you're finding the derivative, what you're really finding is the gradient of the tangent line at one point. So when you're finding first principles, what you're really finding is the gradient. And if you're finding the gradient, there's a couple of formulas for the gradient. You've got y2 minus y1 over x2 minus x1. You've got the first principles, which is the derivative. What else do you also have? There's also another rule that you had learnt. What's also the gradient equal to, besides rise over run? There's also one more. I just taught to my year 11s back in term 1. Gradient is also equal to something to do with an angle. Tan of theta, because that's opposite of adjacent. Opposite of adjacent is the same as rise over run. Okay? So tan of theta is one of the ones that's going to help you to do question B there. So here we go. For the curve, f of x equals 3x squared minus 5x plus 1. It's a quadratic. It's asking you to find the gradient of the tangent line that touches the curve at x equals 2. So on a visual aspect, you can picture like this. You got a quadratic, and at x equals 2, here's the point at x equals 2. There must be a line that's a straight line, and it touches only that one point. Okay, so that's called the tangent line. All it's asking is, what is that line? Okay, and one of the things we know is the derivative finds you the gradient at that specific point, at one single point. So, first thing is you need to find the derivative. So here we go. F dash of x is equal to what? Can I please have Albert? What's the derivative of 3x squared minus 5x plus 1?
6x minus 5.
Beautiful. 6x minus 5. This tells you the gradient function of all the possible gradients that this tangent can have, but I want it at x equals 2. So at x equals 2, because that's where they're saying, I want to know the gradient of that point, then it's f dash at 2 means 6 times 2 minus 5, 12 minus 5, 7. So that now tells me the gradient at that point is 7. I'm almost there. I know that the line is y equals mx plus c, and I just found out m is 7. How do I find c? What do you do? What do you do now? So you use the derivative, you found the gradient. That's your instantaneous gradient at that particular point. So that's the steepness at that particular point. You know that's 7. But to get the equation of a line, you need y-intercept. How do you normally find C? What do you do back in year 9? You did it last year. You did in year 10 as well. What do you need? You got to sub in a point. Now they gave you one x coordinate, but at x equals 2, I can find y. How do I find y? How do I find y? What's the corresponding y value? How do we do it? Because you're right. You do need to sub in a point. You know that you're subbing 2 in, but what would y equal to? Which means, how do I find that y coordinate? Where's the y going to come from? Yeah, because the original equation, f of x, 3x squared, was the quadratic. So at x equals 2, you can sub 2 in to find out what the y value is on the parabola. So here we go. To find the coordinate, you're right. You need to first find what f of 2 equals 2. So that becomes what? 3 times 2 squared minus 5 times 2 plus 1. 4, 12 minus 10 plus 1. And that's 3. Is that right? So that tells me now I've got the point. When x is 2, y should be 3. So to find the tangent line, I just got to sub them in. I'm running out of space. I'm just going to write it over here. That means y is equal to 7x plus c. Sub in 2, 3. 3 is equal to 7 times 2 plus c. 14. And therefore c is equal to 3 take away 14, negative 11. So what's my equation? The tangent line must then be y equals 7x. So that's the instantaneous gradient or rate of change. And it should be a y-intercept of negative 11. That's going to be repeated in chapter 10. So I'm pretty sure it's exercise 10A that you're doing tangents and normal lines. That's the expectation. So you find all the derivative skills and then you apply it. Part B though. Part B says, okay, you've got the tangent line now. So here's your tangent line. But then what's the angle does it make with the x-axis direction? So that's the x-axis. What's the angle that that green line, that tangent line, makes with the x-axis? That's what it's asking. So how do you find the little bit right there? What's the angle? So what I'm saying is, you've got a tangent line, y equals 7x minus 11. Here's your x-axis. You're asking how to find that. Any clues? How do you find the angle that the tangent line makes with the x-axis? Hint is one of the properties I gave to you just before we started this question. Gradient is equal to rise over run, tan of an angle. But we already found the gradient. Remember, just before you told me the gradient, at that particular point, the gradient is 7. So if m equals 7, and you also know it's equal to tan theta, you can equate it together. You can say, well, gradient equals tan of an angle, which I don't know what the angle is, but I do know the gradient. Gradient 7. So now on your calculator, to find theta, that must be tan inverse whatever 7 is. Does it ask for degrees or? I didn't say. Well, I should have specified whether you want it in degrees or not, but I'm going to assume it's in degrees. I don't know. What's my? He's got the answer. What's tan inverse of 7? My Kaz is going to take what to come up. Tan inverse of 7. Okay, yours is an exact value. It's probably in radians form there. You need to convert it to degrees. Sorry, my Kaz is taking a while to load. Has anyone got the answer yet? It's tan inverse of 7. Why is my thing not popping up?
10 inverse of 7 is 81.86.
Sorry, something's wrong with my computer today, so my CAD's not coming up. You got
81.86.
81.86. Is that what everyone else got? Because I just want to make sure you know how to get your answer. Sometimes in the degrees and radians it does matter.
Usually for these questions, they're in degrees, and I've seen.
That's right. I agree. You should be in degrees as well.
When you're doing calculus on the CAS too, it sometimes does different things when you put it in degrees and radians.
Yeah.
Derivatives at a point or integrals over an integral. It gives you a different answer if it's degrees or radians.
That's right. It is very annoying. It's annoying that my CAS also is taking a while to load too. Has everyone got the same as what Pat got? All right. No one else got something different? Because if you got something different, you have to check your settings. But what was the answer you guys got? 81.87 degrees. It's still loading. All right. Last question for today. Example 5. Which should be example 4, but find the value of x such that the tangent line to the curve, so you got x squared minus x, at x, f of x, makes an angle of 150 degrees with the positive direction of the x-axis. Sounds complicated. What am I asking? Good. Well, you're going to need to start off with that point. That's true. The question wants you to find x. So currently you've got x squared minus x. So what does that look like? That's closest to 0, 1. So it looks something like this. 0, 1. It's asking, find the value of x. So where on this x-axis, where I will get a tangent line such that the angle will be 150 degrees. Now, clearly, it can't be where I just pointed because that's an acute angle there with the x-axis. It's likely x value is probably somewhere over here so that you could get an angle that is 150 degrees. So they're asking, what is that x value? And what x value do you need so that the tangent line at that particular point has an angle of 150 degrees? Have a go. I'm going to pause the video. Here we go. Last example for today. So we know that tan of theta is equal to tan of theta is equal to the gradient, but the gradient is equal to the derivative at that point. So we know that tan of 150 degrees should give you the gradient, and that should tell you that derivative of x squared minus x is 2x minus 1. So tan inverse, or tan of 150 degrees. What's that? That's tan of 30, isn't it? Yeah. 1 on root 3. But negative 1 on root 3.
Right, I did not get what you got. That's my final answer. That's not fucking derivative, is it? Is it not? Can I have my card?
You have to sub in and get the name.
Oh,
I didn't get the second time.
Usually I'd probably combine the terms. I wouldn't leave it separate terms.
No.
So I would write it as negative 2 plus 2 root 3 all over 4 root 3. But it's also possible that in exams they don't want you having irrational denominators, so you might have to rationalize denominator as well, so times both top and bottom by root 3. And that gives you negative 2 root 3. Root 3 times root 3, 6, so plus 6 all over 4 times 3, which is 12.
When I did this, I took out
That could be a better answer.
negative 6 becomes a multiplier. And
Do you realize that's 2, right?
Anyone need explanations on the steps I just did? I skipped a few.
yeah, not negative.
So 18 on 9 is